Greetings once again, AP Calc AB students, Mr. Record here, and we've got a really short video here. It's continuing our discussion on topic 1.6. We're in the middle of trying to find values for limits, but we don't have technology, a calculator, a graph, or a table at our disposal. All we have is our good old tools that we learned from our algebra course. And as we go through these videos, we're encountering different kinds of functions that bring different things to the table, so to speak, that are going to require some different algebra. And so in this video, example 7 is all about the conjugate problem. Conjugate, please. So let's take a look at this particular question. We're asked to find the limit as x approaches 0 of the square root of x plus 1 minus 1 all over x. Now, remember our discussion from earlier. The very first thing that you want to do when you're evaluating any limit at any time in this particular course that you're taking is to see if you can directly substitute the value for x right into the expression. Now, if we try to replace each of these zeros with x's, it won't take you very long to figure out that something is not working out very well. You're going to get that 0 value on top, you're going to get a 0 value on bottom, and that is an indicator that you just have to work harder. We don't want to say that the answer is 0 divided by 0 because that's really a bad thing to do on the AP exam. So just acknowledge that that is the fact, and we're going to go into using an algebraic method. Now, the method that we said is the conjugate method. Now, maybe the word conjugate doesn't ring a bell. Maybe you're thinking of the word conjugate, which is something that you might do in your world language classes to verbs. But this is a different form of that word. The conjugate is a binomial expression that has an opposite sign in the middle, right? So in this particular case, we're going to take the square root of x plus 1 and add 1 after it. Now, you can't go around just multiplying fractions by things at your own whim unless you balance it all out and multiply the denominator. Now, in this particular case, we are just essentially multiplying this fraction by the number 1. And so now, might want to think about putting parentheses around all these things, and we actually start to multiply. Now you might be wondering, okay, how is this going to work? Well, stick around and we'll see what happens. And so we've got our limit as x approaches 0. Now, when we look at the numerator, you've got to think back to your algebra courses. Whenever you multiplied two binomials together, you had to do that word, that FOIL word, if you remember, right? F-O-I-L, right? But if you look at this very carefully, something interesting happens with the outside term and the inside terms. Those two products are going to cancel out. Think about it. 1 times the positive square root of x plus 1, negative 1 times the positive square root of x plus 1. So with that in mind, the O and the I really don't play a role in this problem, and so you don't have to FOIL. Instead, you can FLA, I guess, right? Anyhow, let's take the first times the first and the last times the last. So when you multiply these two like radicals together for first times first, we're going to get what's underneath that particular radical. The radical symbol cancels away. And then when we multiply last times last, the negative 1 times the positive 1, we're of course going to get a negative 1. And believe it or not, you've essentially finished the hard part. The denominator is not meant to be the hard part. And I see a lot of students try to overthink this denominator. They're like, oh, I'm so determined to multiply this denominator. Well, just because two things are being multiplied doesn't actually mean they have to be multiplied, if you know what I mean. Make them look like they're multiplied. Just write them next to each other, maybe wrapping that binomial in parentheses, and that will give us the illusion of multiplication. Besides, think about this. Isn't this x in the denominator causing some problems, right? Isn't he causing a 0 to occur down there? And that's no good. So by keeping him factored out, we leave him exposed. We give him a chance to be canceled away. And you might have already noticed that that's exactly what's going to happen. I won't feel the need to write 2 steps to this problem. to get that cancellation to occur. Hopefully you all see that the ones will cancel away. And then you have this lone x term on top with a factor of x on bottom, and those will essentially cancel away. Now they'll make 1 and 1 in both of those spots. And I think at this point, it's probably a good idea to kind of reset and write down our final limit statement before we go any further. Now keep in mind that that numerator becomes 1. Don't be that student that wants to put the 0 there. I've seen that from time to time. If you have a factor that cancels by division out of the numerator or denominator, it turns into a 1. Now the denominator is just going to be the square root x plus 1 expression. And now let's give it another shot. What do you say? Let's see, can we plug that 0 in for the x? And we certainly can. We're going to get 1 over, and you probably don't have to write this step out because you probably see what's going to happen here. But you get the square root of 1, which is 1, plus 1, which is another 1, 2 altogether. And so that means that your final limit is 1/2. And there's so many things that you can do with this. If you wanted to use a piece of technology, you could graph this to see that the value of y is indeed approaching that half. You could look at a table of values, but you're going to get that reinforcement that you need. This is a very typical kind of conjugate problem. The key is for you to compartmentalize these techniques and understand when do you factor and when do you, in this case, use the conjugate. And it becomes really simple if you think about what is it that you would see in the problem that causes you to use the conjugate. The answer would be a binomial expression that contains a square root. Two terms where either one or both of those terms may be a square root. Use that to your advantage, and every time you see it, use the conjugate method. Anyway, I hope this helps. I want you to stick around. We've got a couple more videos to share with you with some more techniques of solving limits by using algebraic manipulation. So until next time, keep studying your calculus, and we'll see you.